Good morning, 7th grade. Today is Tuesday, March 31st. Today we're going to look at Chapter 15, Section 4, Compound Events. Before we get started, just to let you know, I uploaded the Zoom video from yesterday. It is now in Schoology. Hopefully you guys will be able to find it. So let's go ahead and jump right on into this. So we're going to look at compound events. So the first word we have today is sample space. And sample space is the set of all possible outcomes of one or more events. In our first example, we have you randomly choose a crust and style of pizza. Find the sample space, how many different pizzas are possible. Let's move this up. Okay, so again, as always, you are encouraged to pause the video, stop the video, make sure you get the notes in your notebook. I'm going to pause the video and put a sheet of paper underneath the camera. Right back. All right, so we are going to figure out how many different pizzas are possible. So we can have a thin crust, that is Hawaiian, Mexican, pepperoni, or veggie. So that's 1, 2, 3, 4. We can also have a stuffed crust. In the style, we're going to have Hawaiian, Mexican, pepperoni, or veggie. There's 4 more. So the total number of different pizzas is going to be 8. So what if the pizza shop adds a deep dish crust? Find the sample space and then how many pizzas are possible. So what we've done is we've added another crust type with the same available styles. So we've added 4 more types of pizza, which would bring our total pizza to 12. So again, you're encouraged to pause the video. Make sure you get the notes that you need and want in your notebook. Instead of making the tree diagrams, what you could do is use the fundamental counting principle. And the fundamental counting principle says that an event M, notice that's a capital M, has little m possible outcomes. And an event capital N has a little n possible outcomes. The total outcomes would just be m times n. M times n. I'm going to move the book back up here. Remember we said there were 8 different pizzas that were possible here. So if I have 2 here, and 1, 2, 3, 4 here, 2 times 4 is 8. That's using the fundamental counting principle. So either way is acceptable. Finding the total number of possible outcomes. So find the total number of possible outcomes of rolling a number cube and flipping a coin. Go ahead and pause the video. Get this into your notebook. I'm going to pause the video, and when you come back, I'll have a sheet of paper there. All right, so we're going to look at this problem, and we're going to look at 2 different methods. So method 1 is going to be to use a table to find the sample space. And we're going to let H equal heads and T equals tails. Right, so you can have a number cube. We've got 1, 2, 3, 4, 5, and 6. And this side we have heads, and this side we have tails. So we could roll a 1 and flip heads, or you could roll a 1 and flip tails. You could roll a 2 and flip heads, or roll a 2 and flip tails. All right, so pause the video and go ahead and finish out the chart. All right, so you can see I finished out the table all the way to 6, rolling a 6 heads, or rolling a 6 and flipping tails. So this is method 1. Method 1, make table. Method 2, you can use the fundamental counting principle. So rolling a number cube has 6 possible outcomes, and flipping a coin has 2 possible outcomes. Okay, and remember, it's just going to be m times n. So we would have 6 times 2. So there are 12 possible outcomes. So let's check that with our table. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes. So I'm going to put the book back under. So you're going to need to pause the video. You're going to write this problem in your book. So finding the total number of possible outcomes. How many different outfits can you make from the t-shirts, jeans, and shoes in the closet? We have 7 different colored t-shirts, 4 different pairs of jeans, and 3 different pairs of shoes. So pause the video, write the problem down, and let's see if you can solve that. All right, so using the fundamental counting principle, we can say 7 times 4 times 3. So that makes it possible to make 84 different outfits. So see, we don't need all those clothes, all those different types of clothes. We only need 7 shirts, 4 pairs of jeans, and 3 pairs of shoes, and we got 84 outfits ready to rock and roll. Okay, so how about this question? How many different outfits could you make from 4 t-shirts, 5 pairs of jeans, and 5 pairs of shoes? So using the fundamental counting principle, we multiply those together. Well, 5 times 5 is 25, and 25 times 4, that's 100 different outfits. That is correct. All right, so here is the last part. We're going to look at compound events. A compound event consists of 2 or more events, and it's the ratio of the number of favorable outcomes to the number of possible outcomes. So we're going to use example 3. We're going to go back to that, the ones with heads and tails in the number cube. What are the possible outcomes of rolling a number greater than 4 and flipping tails? Go ahead and pause your video and get those examples in the book. All right, so remember, we're looking for the ratio of the number of favorable outcomes to the number of possible outcomes. And again, let's look back in the book, in your notebook. We are looking for the possible outcomes of rolling a number greater than 4 and flipping tails. So there's only 2 favorable outcomes that would be. That would be 5t and 6t. And remember, we determined that there were 12 possible outcomes. So this is equal to 2. So you have 2 over 12, which equals 1/6, or 16 and 67/100%. Times 100 would be 16.67. All right, very good. All right, one more example. I'm going to have you write this one in your book. Here we go. You flip 3 nickels. What is the probability of flipping 2 heads and 1 tails? So pause the video. Go ahead, if you can, find yourself 3 different colors. I'll probably have a red, a green, and a blue. So go ahead and pause the video. All right, so we are going to have our first coin, our first nickel. And that can be heads or tails. And then our second nickel is going to be heads or tails. And then it's also going to be heads or tails here. And then this one can be heads or tails. Oops, sorry about that. This one, this is the third nickel. This one's going to be heads or tails. Again, we're going to have heads and tails. Here we're going to have heads and tails. Okay, so if we follow the branches out, we can have H, H, H. We could have H, H, T. We could have H, T, H. H, T, T. T, H, H. T, T, H. T, T, T. I left one out. Let's see. T, T, oh, T, H, T. T, H, T. All right, so our question is, what's the probability of flipping 2 heads and 1 tail? So 2 heads and 1 tail. So head, H, H, T. 2 heads and 1 tail. And 2 heads and 1 tail. So the number of favorable outcomes is 3. The number of possible outcomes is 8. So it's 3/8, or 37.5%. All right, so from here, you're going to head over to Schoology to do your exit ticket and your textbook assignment. Can't wait to see you guys tomorrow. Hope you have a good day.